This is Production Logging Services Tracer Ejector Tool. This is a demonstration unit. It's got a plexiglass fittings on it. This is the downhole version. It's 1 3/8 in diameter, about 3.5 feet long. And the way that it operates is pretty simple. This barrel, there's a piston in the barrel. This is the piston. You can see the black seal on it. Right now it has red colored water for demonstration purposes. And the shaft is hooked to welded to the piston. And then the shaft comes in here and is attached to the lead screw housing. And there's a DC motor. It's got a transmission. This is the motor. This is the transmission. And then it's hooked to the lead screw. So as the motor turns clockwise, it will pull this piston forward. When the motor rotates counterclockwise, it'll push the piston. So in operation, normally this tool is filled with radioactive iodine or tracer material. We fill it and then run it in the hole, and then we can pulse this motor. And this is the funnel that you fill it with. And normally there's a tiny port in it with a very tiny hole in it. There's the port that came out of this tool. And we can pulse this tool from the surface and get this piston to move incrementally. Or we could run it continuously if we want. Normally it's like maybe a 1 second or 2 second movement, and it'll get like a half a cc. The nominal capacity when full is 30 cc's. The practical is more closer to 25 cc's. So basically the way this operates is on the lead screw housing. There's two contacts, the lower contact and the upper contact. And as you can see, they're insulated by these Teflon insulators from the main body. And so when this lead screw hits this contact, it short circuits this relay. So this is just a double pull, double throw magnetically latched relay. So this is a DC motor, so it turns one direction in the plus minus mode, then it turns the opposite direction in the minus plus mode. So when this contact comes down, shorts out this contact, it swaps the polarity on the motor through this relay. And so plus becomes minus, minus becomes plus, and then it reverses the direction of the motor. So in operation, when we're filling it, it'll fill this way. We'll put this funnel in it. When we fill this, we just remove this port, screw the funnel in, and on our power supply, we have an audio. We can actually listen to that motor running, and we can hear that switch at the end. So we'll fill this full of the radioactive material. We'll cycle the piston all the way back. When it switches, we'll let it run for a few more seconds. We'll remove the funnel, replace it with the port, run in the hole. For fluid sampling, what we would do is we would empty it all the way. We leave this port out. Then we would go to the station where we want the sample from. We would run it so the thing would fill up, and then we could hear it switch, and then we would stop, come out of the hole, install the funnel, and then empty it. These run on either positive current or negative current, and so we can run two of them in series with each other. So we would have one tool sampling when we run on positive current, one tool sampling when we run on negative current. There's a close-up of that little relay, and all the wires going into the motor, the switching circuit, the steering diode. So right now I'm going to operate it, and you'll be able to hear that motor running. So right now it's filling. So I'm going to go ahead and short it out. So it reversed direction, and now you can see that piston moving up. And so it's pushing fluid out. So now the tool is emptying itself. And when that contact hits this, when the housing hits this contact, it going to reverse the polarity of the motor. So now it's filling itself. So this is the mode that would be in if we were taking fluid samples. Pretty simple. I'll stop it right when it fills all the way. Again, the water's just dyed red for demonstration purposes.